Binary Brain YouTube channel. Today I am going to explain a sorting type in data structure algorithm called quicksort. What is sort? Sorting means arranging data in a specific orders, usually in ascending or descending order. Sort එකක් කියලා කියන්නේ දත්ත අනුපිළිවෙලකට අනුගමනය කරලා සැකසීමක් කියන එකට. ඒක ආරෝහණ ascending වගේම අවරෝහණ descending පිළිවෙලකට හදන්න පුළුවන්. There are many types of sorting algorithms, each with a different way of arranging data. Slow, bubble sort, selection sort, insertion sort. And the merge sort, quick sort, heap sorts are fast. And counting sort, radix sort and bucket sort are special purpose. But today I am going to talk about quick sort with you all. What is quick sort? Quicksort is a fast and efficient sorting algorithm that works by dividing a large list into smaller parts and sorting those parts individually. It uses method called divide and conquer, meaning it breaks the problem into small pieces, solves each, and then combines them to form the final result. quicksort කියලා කියන්නේ ඉතාමත් වේගවත් වගේම කාර්යක්ෂම sort algorithm එකක්. ඒක divide වගේම conquer කියන විදිහෙන් තමයි වැඩ කරන්නේ. ඒ කියන්නේ අපිට පුළුවන් ලොකු ගැටලුවක්, ලොකු problem එකක් කුඩා කොටස් වලට කඩාගෙන ඒවා වෙන වෙනම විසඳලා ඊට පස්සේ ඒවා එකට ගලපන්න. Steps of quicksort. First one is choose a pivot element. Pick one element in the list. This is a pivot. The pivot can be the first, last, middle or random element. මුලින්ම අපි කරන්න ඕන pivot එක තෝරගන්න එක. මේ pivot එක array එකකින් element එකක් තෝරලා pivot එක විදිහට තමයි ගන්නෙ. මේ pivot එක මුල, මැද වගේම අග element එක. Second one is partition the array. Rearrange the elements so that element is smaller than the pivot come before it. Element greater than the pivot come after it. ඒ කියන්නේ පාර්ශන කරද්දී pivot එකට වඩා අඩු number එකක් තියෙනවා නම් ඒක වෙනස් පැත්තට වදින්න pivot එකට වඩා numbers වැඩි නම් ඒක දකුණු පැත්තට අපි අරගෙන යනවා. The third one is recursive sorting. Apply the same process to the left and right parts. The fourth one is combine results. Finally the list becomes sorted when all small parts are sorted. ඒ කියන්නේ අන්තිම එක අවසන් වුණාට පස්සේ සියලුම කොටස් සෝට් වීමෙන් පස්සේ මුළු array එකම සෝට් කරන විදිය තමයි මෙතෙන්දී අපි කියන්නේ. Why quicksort is fast? The first one is it divides large problems into smaller ones. මේ quicksort එක අපිට ඇත්තටම වටිනවා ලොකු ගැටලුවක් පොඩි කොටස් වලට කඩලා විසඳන්න. ඒ කියන්නේ මුළු ලිස්ට් එකම එකපාර සෝට් කරන්නේ නැතුව කොටස් කරලා සෝට් කරන හින්දා මේකේ වේගය වැඩි වෙනවා. ඒකට අපිට උදව් වෙනවා divide සහ conquer කියන විදි දෙක. උදාහරණයක් ගත්තොත් අංක 100ක් එකපාර සෝට් කරනවට වැඩිය අංක 50 අරගෙන ඒක දෙපාරකට සෝට් කරලා එකතු කරන එක තමයි ගොඩක්ම වේගවත් වෙන්නේ. Second one is in-place sorting. It doesn't need extra memory. quicksort එකට අමතර memory එකක් අවශ්‍ය වෙන්නේ නැහැ. මොකද ඒක එකම array එක ඇතුලේ in-place data වල position mark කරලා sort වෙනවා. ඒ හින්දා memory usage එක අඩුයි වගේම අනෙක් sort algorithms උදාහරණයක් විදිහට merge sort වලට වැඩිය ගොඩක් කාර්යක්ෂමයි මෙන්න මේ කියන quicksort එක. The third one is, on average, it's faster than bubble sort or insertion sort. සාමාන්‍යයෙන් quicksort එක බබල් සෝට් සහ ඉන්සර්ෂන් සෝල්ට් වලට වැඩිය ඉක්මනින් වැඩ කරනවා. ඒකට හේතුව තමයි ක්වික් සෝට් එක අවශ්‍ය කම්පැරිසන්ස් ගාන අඩු කරන හින්දා. බබල් සෝට් එකේ හැම එලිමන්ට් එකක්ම කම්පෙයාර් කර කර තමයි යන්නේ. හැබැයි ක්වික් සෝට් එකේ අවශ්‍ය කොටස් විතරයි අපි කම්පෙයාර් කරන්නේ. ඒ හින්දම එක්සිකියුෂන් වල ටයිම් එක අඩු වෙන හින්දා ක්වික් සෝට් එක ෆාස්ට් කියලා අපි මෙතෙන්දි ගන්නවා. Let's understand how quick sort works now. First, let's take a set of numbers in this order: 10, 6, 11, 8, 12, 2, 9, 15. The numbers 0, 1, 2, 3, 4, 5, 6, 7 are the index numbers. The number 10 is the lower bound and 50 is the upper bound. We start the sorting process from 10 and end at 15. As mentioned before, a pivot is a number chosen from the set. It can be the first number, middle number, or last number. In this example, we are taking a pivot as a number at the start, which is 10. Quick sort algorithm is step by step. The first step is choose a pivot. Here, we all take the first element as our pivot, which is 10. The start point is get right after the pivot, and the end point starts from last element. The pivot is 10, show arrows. The start index 1 is 6, end index is 7, the element is 15. Quick sort algorithm is step by step. The first step is choose a pivot. Here, we all take the first element as our pivot, which is 10. The start point is get right after the pivot, and the end point starts from last element. The pivot is 10, show arrows. The start index 1 is 6, end index is 7, the element is 15. Start comparing and swapping. Now we compare elements from both ends. The goal is simple: put all elements smaller than the pivot on the left and the large element on the right. First, compare the voice element 6 with pivot 10. It is smaller, so move the start forward. Next, start point to 11, which is greater than 10, stop there. Now compare the end element 15 with pivot 10. It's greater, so move the end one step left. End now points to 9, which is smaller than 10, stop there. Since star is less than end, we swap them. Swap 11 and 9. Before swap 10, 6, 11, 8, 12, 2, 9, 15. The after swap is 10, 6, 9, 8, 12, 2, 11, 15. Let's move the pointers again. Start moves to 8, which is less than 10, so keep doing. Then so 12, which is greater than 10, stop. Move the end point backward. Now it is at 2, which is less than 10, stop. Swap those two elements. Swap 12 and 2. After swap is 10, 6, 9, 8, 2, 12, 11, 15. Now the start pointer has crossed the end pointer, which means the partial step is done. The next step is to place the pivot in its correct position. Swap the pivot 10 with the element at the end pointer position, which is 2. Final, after partition 2, 6, 9, 8, 10, 12, 11, 15. Now step 5, divide and conquer. Now our pivot 10 is in its correct place. Everything on the left of 10 is smaller and everything on the right is greater. We all now apply the same process recursively once for the left side, 2, 6, 9, 8, and again for the right side, 12, 11, 15.
The step 6 is final sorted array. After applying quick sort on both hells, the entire array becomes completely sorted, and our final result is 2, 6, 8, 9, 10, 11, 12, and 15. So that's how quicksort works. It's called divide and conquer because it keeps dividing the array into smaller parts until everything is sorted. I hope this step-by-step explanation help you understand the logic clearly. Java code explanation. Public class quick sort example. Declare public class name quick sort example. All the quick sort methods and the main function will be inside this class. Static in partition into array in low in high. The array is set to sort. This static method called partition. The parameters low is starting index of the subarray, high is ending index of the subarray. The purpose is divide the array into two parts around the pivot. Int pivot equal array low. Choose the first element of the subarray as the pivot. All element less than pivot will go left, greater than pivot will go right. After 4 is initial pointers. Java int I equal low plus 1 and int j equal high. I is pointer starting just after pivot. J pointer starting at the end of the subarray. This pointer used to scan the array to find element to swap. The fifth one is called in the temporary variable for swaps. In temp is temporary variable used to swap two elements. The infinite loop, the while is to the infinite loop. This loop keep running until we break it manually after partition is done. Move star pointer. The while I less than or equal j and an array I less than or equal pivot I plus plus. Move the star pointer to the right as long as I is within bound. Array greater than or equal pivot. Stop at the first element greater than pivot. And while I less than or equal j and an array j greater pivot j minor. Move the endpoint j to the left as long as array j greater pivot stop at the first element less than or equal to pivot. The check pointer cross if bracket I greater than j break. If start pointer I has passed end pointer j, partition is complete. Exit loop. Temp equal array I equal array j equal temp. The swap the element at I and j. This code in the code purpose is move smaller element to the left and larger element to the right. And temp equal array low equal array j equal temp. Swap the pivot element with array j so that pivot is in its correct sorted position. All element left of pivot are smaller, right or larger. And this called Java return j. Return the index of pivot after partition used by quicksort to recursively sort left and right sub array. And static void quicksort in array int low int high. And method to sort the array recursively low start index high end index of the current sub array. If low less than high, only sort if the subarray has more than one element. In the pivot index equal partition array low high. In pivot index equal partition array low high. Partition the array using the partition method. Pivot index is the correct position of the pivot after partition. And quicksort array low pivot index -1, quicksort array pivot index +1 high, sort left sub array elements before pivot, sort right sub array element after pivot. This continues recursively until the whole array is sorted. Public static void main string args. Entry point of the program code inside main will execute when you run the program. Int array 10, 6, 11, 8, 12 to 9, 15. Int n equal array.length. Define the array to sort and stores the size of the array. Quicksort array 0, 9, n -1. Call quicksort on the full array from index 0 to n-1. System.out.println double quotation sorted array for in num array. System out print num plus double quotation. Print sorted array loops through the array and prints each element separated by space. This output. Python code explanation. The first line 1, def quick underscore sort array. This defines a function named quicksort. It takes one argument array, which is a list of numbers to be sorted. Everything that happens inside quicksort will work on the array. The second line, if len array less than and equal 1, return array. This is the base condition for recursion, and if the array has one element or is empty, it's already sorted, just return it. Without this line, the function would never stop calling itself. Infinite recursion. To example, if array equal to, since length equal 1, return to directly. Line 4 is Python pivot equal array 0, the first element as pivot. The first element of the array is selected as the pivot. The pivot acts as the divide line. Smaller element go left, larger go right. The array is 10, 6, 11, 8, then pivot 10. Left equal x for x in array 1 if x less than or equal pivot. This line creates a new list called left using list comparison. It looks at all element expected pivot. Array 1 means from second element to end. It checks each element x, and if it's less than or equal to pivot, it adds x to left. So L6 is right equal x for x in array 1 if x greater than pivot. This create another list called right. It also look at all element expect the pivot. If an element x is greater than the pivot, it goes into right. The example is for the same array, element greater than 10 are 11, 12, 15. So write 11, 12, 15. Return quick sort left, combine pivot, combine quick sort right. This is where the recursive magic happens. The function calls itself on both sub-array. Quick sort left sorts the small elements. Quick sort right sort the larger element. The results are combined in order: sort left, combine pivot, combine sorted right. The example flow 8, 6, 8 to 9, combine pivot is 10, combine quick sort 11, 12, 15. That new array is 2, 6, 8, 9, 10, 11, 12, 15. Array equal 10, 6, 11, 8, 12, 2, 9, 50. This is the array we want to sort. It's unsorted at the beginning. The sorted array equal quick sort bracket array calls a function quicksort on the given array. The function returns a new sorted list which is sorted in sorted array. After sorting, sorted array 2, 6, 8, 9, 10, 11, 12, 15. Print double quotation sorted array, sorted array. If you print this message sorted array followed by the sorted list is output sorted array 2, 6, 8, 9, 10, 11, 12, 15. So today we discuss what quick sort is, how it is work, and the code explanation as well. I will see you again next time with another new video. Have a great day everyone.